I'm a PhD student at Syracuse University, and I use some AI or machine learning or deep learning technique to study figures. And so I know a little bit about convolutional neural network, and I want to share with you my knowledge on this topic with you. So this is the agenda of my presentation. First, I will introduce the purpose of convolutional neural network. Then I will introduce the background and the concepts and neural network design, implementation, the use case, and we will have a small practice with my codes, and you can try yourself, and we can see how we can apply it to our own research, and then I will do a summary of this topic. So when we think about neural network, we might think about brain, and actually brain can do many things. One thing is to help our vision system to understand image, video. And interestingly, different animals see things in different ways. Their vision system are different. And if you take a look at this plot, you can see human and rat see things very differently. They have same background. And now we can move to the background of the convolutional neural network. Actually, convolutional neural network is one of the most successful biological inspired AI, and it is guided by the design of human vision system and other disciplines. As Daniel introduced in the previous lecture, you might learn that different area of brain have different functionality and they do different things, and all these work together, we can see things clearly. And the convolutional neural network is also inspired by this idea, and you have different layers and different layers do different things, and then they can and finally we can understand the image for some purpose. And before we look at more deeply on convolutional neural network, we first need to review several concepts. First is convolutional operation, and then we can take a look at neuron and the sparse interaction, parameter sharing, and pooling. So first of all, when we talk about convolutional neural network, what is convolution? And the convolution is mainly referring to convolution operation is an operation to average on several measurements to reduce noise in the data, preferring recent data. So if you take a look at this formula, you might have some idea. So this we have the raw data which from X, and we need to compute the data either the point T, what is the feature is about, and but we don't, to reduce noise, we don't use only the feature the feature or the data in point T. We use all the data around it, because we have in time we have some near neighbor data point. We can reduce the noise to help us to have a more accurate representation of the data, and we can do this summarization or data points around it, and we have the feature that is averaging on several measurements to reduce around the data point. And now we talk about the neuron. Neuron is according to this illustration. So we have the illustration, we have different we have inputs, and we have this kind of this part in the neuron that can process the input, and they have some output. So similarly, in convolutional neural network, we have a function that we take different input, and we have activation function, and we have output, like just like introduced by Daniel in the last lecture. So after we have seen neurons, and you might have tried the playground, you have layers of neurons, you connect each other, and interestingly, in convolutional neural network, we use sparse connection. So the inputs don't connect to every neuron in the next layer. However, in some other neural network, we use full connection. So one neuron is connected to every other neuron in the next layer. And another interesting mechanism in convolutional neural network is parameter sharing. So parameter sharing is that, as we see that here, we have this function, we are weighting, like we have a weight on the different data point, and we need to learn the parameter of how much weight we have. And here, with parameter sharing, all the neurons in this in one layer use the same parameter, and but without parameter sharing, we have different parameter for each layer, each neuron in the layer. And the last thing I want to introduce is pooling is also a very important step in convolutional neural network. Is it can summarize the output from previous layer and with a statistical analysis, and then we can avoid some small shifts in the input to the next layer. So if you take a look at this plot, you can see that after the pooling stage, some minor difference are ignored by the after the by the pooling stage. So now I will introduce neural network design. Basically, it is we have some input, which is the data, and then we have hidden layers of neural networks, and then we make predictions. And for convolutional neural network, more specifically, so we have different kind of layers. First is convolutional stage. So we do the computation on the data and we transform it with convolution operation, and then we pass it through activation. So you might do this. It's called detection stage. We have some activation function, and after we have the activation function, we have the output from the activation function. We do pooling as I introduced before. So we process the output to reduce some small shifts in the data. And basically, this is a neural convolutional layer. What is convolutional layer doing? And we process it. We have another layer. We can go on and on. And those are the very basic idea behind convolutional neural network, and we have some very different ways to implement it because we have many variations, and the researchers are proposing many different architectures. And for example, one different way is how to connect the neurons. One way is to do local connection. If you take a look at this, you will see that each neuron have its own parameter, and another one is convolution connection. Is similar to what I mentioned before. Is the parameter sharing. So the each neuron have in the same layer have all the same parameter, and also we have the full connection, and each neuron each input is connected to different layers, and we also have a different. So those are the different structures, and so it's another kinds of variation on the parameters, and we have a local connected is similar like introduced before, and we have tilt convolution is that those two neurons have a group of parameter, and next group of neuron have the same parameters. And we also have standard convolution is that each neuron in the neural network have the same parameters. And those are the previously was the basic ideas behind a convolutional neural network. And now, because we are not, at least myself, I'm not computer scientist, so I'm more caring about how to apply it. Even though like understanding them are very important, but I'm more care about how to implement it, which implementation I can use. And here there are two kinds of package that are very mature and well maintained. One is TensorFlow and another one is PyTorch, and they are very helpful. You can run convolutional neural network with it, and both of them are written by Python. And but unfortunately, TensorFlow might not be supported by Google anymore, and it will be mainly maintained by the community. But you can try both. I think both is helpful. Depending on my task, I might try TensorFlow or PyTorch. And in the practice, I will show you how to use it with TensorFlow because that's the code I use. And back to CNN, convolutional neural network. Convolutional neural network perform very well on object recognition and image classification. And actually, in science of science, we have so many scientific figures, and we can really use those techniques to help us to analyze, to understand the figures. And one example is that we can separate compound figure from other figures so that we can do more analysis on compound figure, or even we can do we can make sure that the figure we analyze is a subplot, so that we can do some specific analysis. And now is the time we can do some practice. And so this practice is that we can try to classify scientific figures to categories. For example, we can classify a group of figures to bar chart, line chart, box plot. Actually, someone had like Professor West from University of Washington. They have done this task before, and they did analysis on the distribution of plots in scientific publications. And actually, it is given the help of convolutional neural network, you can do it yourself. And I prepared this practice with you so that you can try to do this task. And if you are interested in this paper, maybe you can read the paper and see how you can do it even better than Professor West. So now I'm going to show you the code to see how I did this, like classify charts into categories. So let me see. So actually, I prepared two codes. This code is what I used in the last summer school, and by that point, I think it works very well. But as you know, that packages change frequently, and we have new functions, and the packages fix its bug. So I do another version is based on the newer package, and we have some improvement. But I want you to try the new version yourself. But I will introduce the old version I have, and both are available in the CN demo, and this is the new one. And basically, you can just run each cell, and it will help you to load packages, and it will detect that. And so basically you can, and we do data augmentation. So we load the data, and in data augmentation, we process the image, and we rotate it and switch it, look like this. And internally they do it. I didn't show it explicitly. And then we load the data, and then we build the model, and we use ResNet with residual network. It is a kind of convolutional neural network, and we build on this network. We we try to make predictions by modifying the network. We add another layer on top of, remove its original top layer, and make another layer on top of it to make predictions. Basically, this is a way that we use the network as a feature extractor, as Daniel showed before, that the network can do feature engineering itself. And if we take the feature from ResNet and we add another layer to make predictions on our own task, that's what I'm doing. So, and we load we prepare the model, and then we fit it to learn. And actually here we prepare the data set. So I have already put it in the training folder, validation folder, and test folder, and so we load the data, and now it's training on the training data, and we validate on the validation data, and it might take some time because our it's running. So basically the accuracy is increasing, and we can validate it, and this is the score we have before and on each task. And you can try your own figure and here. And for your own practice is that this is the neural version on the data set. So on this task, this is the code I like because it is based on it's a neural version of based on the neural version of TensorFlow, and this some function here might be relatively old, and here I plot each figure, and I do was the outcome of data augmentation. I do the flip and rotation of data augmentation. Why we need to do data augmentation is that we can try to maximize the value of figure our data. So we change the rotation or flip the figure a little bit to avoid that you don't to help the neural network learn better features. And because they are the same figure, but you just look at it in a different angle, so it will really create many features. And as we learned before, is that a neural network needs a lot of data. So if we like change the angle and modify it a bit, we have more and more data, so that we can really increase the number of data points. And then it's basically the same thing after we do the data augmentation, and we load the model, and we add a layer on top of it. But there are many key things, like we are doing a multi-category classification. We need to choose the right loss function. And when you do binary classification, you can try binary cross entropy. And you can also try, you also need to do some modifications on the top layer, the prediction layer here. So here we have 7 class, so I dense it to 7. And if it is it's one category, you dense it to 1. And this is the same thing, and you fit it, but you need to run it yourself. And here is the output. I ran it last night, and it is we take the model, and we let it output the probability after add a layer of softmax. And here is the outcome, like this is a line plot, and I give it a label, and scatter plot, bar chart, heat map, violin. And so this is the outcome. Now here is still running. but at least the performance is increasing, and I believe that at some point it will be pretty high like this, and you can play with it yourself. So so I just want to show you that there are some ways to apply those complex neural network in an easy way, and you are welcome to explore both Jupyter Notebook in the library and play with it and learn how it works, how to make it work, and I'm happy to help. And so that's basically the main content in this presentation. Do you have any question about this presentation before I wrap up the whole presentation? Okay, so if there's no questions, then I will move on. So this is a summary, and convolutional neural network is inspired by human vision system, but they are not exactly same. They are also guided by other disciplines such as engineering, and the development of convolutional neural network is ongoing, and the new architecture of convolutional neural network are published very frequently, like even in a couple of weeks or a couple of months, and new architecture will be published. And so, but the basic idea is still in this lecture, but there are many variations. And the ResNet is a very successful neural network. You can do it, or you can try it with image classification. But there are all new architectures you can try, but it's just very accessible. So this is my presentation, and you're welcome to try both code and play with your own problem. And if you have any question on image analysis or computer vision or convolutional network, you can feel free to reach out to me, and I would like to help you and discuss what you need to do. Yeah, thank you very much.
Thank you so much, Han. So great.